good evening, good afternoon, good morning, or maybe even good night if you are in one of those time zones where it's night currently. My name is Jiří Chinchura. I am a senior software engineer in the EF/data team. And in next 30 minutes, I would like to talk to you about all the different new features and improvements we've done around in data. So our agenda, I will be talking about our Cosmos DB provider for EF, then improvements in EF in general, and then I will touch on the vector databases, although I will touch the vector databases throughout my demos. So let's start with the Cosmos DB. So what we've done with Cosmos DB is that we rewrote a lot of stuff internally in the provider, basically removing all of the relational prejudice and making it feel more like a first-class citizen in the document databases world. So we have a lot of improvements in the query pipeline. We have a support for more mapping scenarios like primitive collections. We are now translating way more link queries and so on. We have support for partition keys that are hierarchical. We obviously have a lot of performance improvements, and we also have a preview for a vector search. So let's jump into Visual Studio and let's have a look at how it looks like. All my demos throughout this presentation are actually going to be using roughly the same structure. So there's a class doc with a bunch of properties like name and the breed and some context that is a minimal context to configure the EF for this demo. So what I have in here is a class that's being mapped into a container. In this case, it's a container docs, and it has one partition key that's called breed. And I have here two queries. The first one is matching the partition key and then some extra condition. The other one is matching the partition key and an ID as well. And if you know a little bit about the Cosmos, you know that if you know the partition in advance, you can send it through the SDK as part of the query, not part of the SQL. And same for the ID. If you know it in advance, you can send both of those throughout the SDK, and it will be a little bit more performant, a little bit more easy because it does not go through the query itself. So now if I run this application, what we will see is that for the first query, we actually extract the partition key and put it into the SDK. So there it is. It says in partition Dachshund, and then I have only the starts with condition itself. For the second query, let me put it in there so we can actually see it, where we have both the partition key and the ID as well. We extract both and say, hey, we can do this a little bit more efficiently. We can do immediately reading the item from the database. So basically say, hey, this is the ID, and this is the partition. So pretty easy and immediately available to use. So performance improvement and also the quality of life improvement number one. Speaking of IDs, let's check the partition keys that are hierarchical. So let me jump into this one. Again, the same setup. The only difference is that I have extra partition key that's available there on its continent, and it's set up as the continent and the breed. Slightly different container because obviously I need to set up the partition keys as hierarchical in the container itself. So in this case, I have the same query. I'm querying on the breed and then the condition on the name, same as before. And now I have both available in there, both parts of the partition key. So if I run the first one, we will see, because we don't have the full partition key available. In fact, it's only the second part of the partition key. It's part of the query, and it's going to be, as usual, like going through the processing of the full SQL query. While for the other query, let me put it again back in there so we can see it. We extracted again the Europe and Dachshund as the partition key, put it through the SDK, and the query itself is using only the condition by itself. So again, like quality of life improvement, performance, maybe even like the cost optimization, because this one will obviously be a little bit easier and a little bit faster. So speaking of querying, we've improved the querying as well. So let me open another one. And this one is kind of matching the mapping as well as the querying itself. So now it's slightly different because now I have this collection, this array of datetimes that are available for the shows that the dog was at or something like that. So these collections and document databases, that's like a natural fit because I can put this array of datetimes as part of my document. It's what the document databases are good at. For a relational, you would probably have like a different table or maybe embed it as a JSON or something like that. If it's a different table, we need foreign keys and other stuff. For document databases, it's no-brainer. It will be part of the document. Now you can do the mapping just as you would do on a relational with so-called primitive collections. But we also have a great story for querying capabilities. So in this case, I'm querying for the count of the items in the shows. So this is the first one, having a condition on top of that. And the next one, which is my favorite one, I'm getting the first element from this collection, whatever the first might be, and I'm checking a property year from inside this one. And the year itself is part of the date time. So we need to extract it from this value and then compare it to 2024. Finally, to show you some a smaller item, and you can definitely go through the list on our repository where everything is being tracked. I'm also doing the starts with, but now with the ordinal ignore case, because Cosmos DB allows you to specify optional parameter whether you want to do case sensitive or case insensitive search, and we now support the translation of this argument. So again, let me run it. No major surprises. So first we use the array length and check it whether it's greater than 10. That's probably pretty nice. The next one, my favorite one, is something, and again, let me move it a little bit further down, is something that you would probably came up with after a couple of minutes of trying, but again, it LINQ and C#, it's a little bit easier than coming up with it in querying language. It takes the array, extracts the date time part for the 4-digit year, then takes the first one and compares it with 2024. And finally, the starts with method with the parameter true, saying, hey, I want to do the case insensitive search. So all this is about querying and making your life a little bit easier with matching what actually you would like to have in a database. There is also one feature that I would like to mention in this case, and that's, as I said before, making sure that the Cosmos DB mapping and behavior of EF matches the expectation of what you would have from writing it manually or something like that. So what I have in here is the same model, everything like that, but now I'm not doing any querying. What I'm actually doing is inserting the data. So I'm inserting some kind of data and calling save changes. And if I run this application, we will see that it inserts something into the database. Let me jump into the portal and refresh what I have in here. Let me do it this way. Come on. Okay, let me refresh the full page. It will be probably faster and easier. Come on, come on. There it is, items, and we can see it's there. Pretty simple stuff, but a small piece. Look at this ID. It's just the GUID, the same GUID I've put there in my application. No extra pipes, no extra stuff in there. It's just as you would do it, let's say, manually or something like that. We have the partition key being dark-zoned, and we have the type that we need for EF to know, what is this one. And it's just, again, using something that would be, let's call it natural. It's called $type, so we know what type of entity is there. Quality of life, and basically making sure that everything aligns with general expectations. If that's it, we are super happy about it. Before I leave from the Cosmos world, I want to give you a sneak preview of something that's available and you can use it, and it's vector search. You can use the vector search on Cosmos DB. It's still in preview and you need to manually enable it. But now, even if you enable it on your Cosmos DB instance, you can use it quite naturally throughout the EF. So what I have in here is a bunch of embeddings that I will be using for my vector search. And I have a property where I'm saying, hey, this property is vector. It's using cosine as the distance function, and it has some kind of dimension. Does not really matter for us. And now I can query my data using this EF function's vector distance function, where I can specify one vector and another vector. I take 5 of those elements and get it back and doing the vector search. So if I run it, nothing super magical will happen. I have this random vector that I generated. Normally you would use probably some language model to generate the embedding. I just used random numbers. And now the translation calls the vector distance function with a bunch of extra arguments that you don't have to worry about, because EF will do it for you naturally. Speaking of the vector search and vector stuff, we have the same feature in EF. So before I jump and do the EF stuff, let me jump into another program and open the EF implementation. So you can see that it's basically the same code. We have still the embeddings. We are specifying that it's a vector using, in this case, SQL Server, and its vector type that's available in there again as a preview. I'm specifying, hey, use the SQL Server and use the vector search, and I'm doing the same query now on the SQL Server. So I have the vector distance using the cosine and bunch of arguments to do stuff. In this case, I'm using a plugin package. Hopefully, when it's available as a stable feature in the Azure SQL, we will have it as part of the EF. And now it's called EF Core SQL Server Vector Search. It's the version 0.2. It's available on NuGet. It's public. It's available on GitHub as well. And we are maintaining it. It's absolutely fine. So you can give it a try, and eventually we will integrate it into the EF, because it will be integral part of that one. So if I run it, we will see that the table is slightly different. We can see, hey, there's the embeddings. This is the vector data type with 1536 as the size. And here is my query. If I scroll all the way down, we can see now it's using the vector underscore distance function with a bunch of arguments. Again, you don't have to worry about it. EF will do it for you. You just say, hey, this is the first vector, this is the second vector, this is the distance I am interested in, and do the stuff for you. Which brings me to the EF. So let me bring you back the slides. And EF was, again, improvements across the board. We've improved our modeling scheme with other stuff that are available now, some extra options that you can use for modeling. We've also continued working on our query pipeline, giving you some smarter and more performant link translations. Especially the performance part is definitely something that we are proud of, because we are making sure, or trying to make sure, that the queries we are producing are not only correct, but also the best possible for that type of query. We've improved migrations and seeding. We have the vector search as the preview available as well, and also the native AOT as a preview. I will show you that as well. So let's jump back into the VS. We don't need the EF vector search, and let's talk about the migrations. Migrations are great, easy to manage your database and stuff. There is also one problem with migrations. If you are deploying your database changes as part of your application startup, especially in a distributed environment, it might be difficult to make sure that only the first application, only the one application that's starting will apply these migrations. If that does not happen and two applications start at the same time and both applications see, hey, I'm in a version that's too old, I need to upgrade my database, they will collide with each other and it will end up badly. If you are doing the database migrations as part of the deployment, that's obviously a little bit easier, but it's not always the case. So if you're running in a distributed environment and you don't control completely when something is starting or not, then this is definitely for you. So what I have in here is, again, the same model, same stuff, but I also added a first migration. It's called first, and it's basically adding the first table that I'm using. And now, as my application is starting, I am calling migrate async, kind of on a startup to migrate my application. If I run it, we will see a small magic trick that we are doing, but it's quite nice and you will definitely love it if you are working in a distributed environment. Before migrations, we take a lock, meaning that if other application starts at the same time or really close to that one, as would be in a distributed environment, and you have like a multi-node or something environment, only the first one will take the log and the other one needs to wait. Then we do the migration history table, then we do the docs table that I have, then we note, oh, we did the first migration, and finally we call sp release uplog, which is specific to the SQL Server. If you are using a different database and different provider, they will provide their own implementation themselves as well, based on what the database offers. So now, if your application is starting, you don't have to worry about applying the migrations like twice or across each other and possibly failing, because obviously if you try to create a new table and the table was created a millisecond before, it will obviously fail. So pretty nice improvement. Continuing with our story, we have a new way of doing seeding. I don't know whether you've ever done a seeding, but originally it was part of the model, which was probably not the best place to have it, especially if you need to do stuff like make sure the data is there, not overwrite it, maybe delete some data as part of your like moving the database forward and other stuff. So what we have now is a new way of seeding, and I would strongly recommend you to start using this one if you are using seeding, because it's so much nicer. And it's called use async seeding if you are doing the asynchronous version, or if you want to use the synchronous version, it's called use seeding. Again, I would definitely recommend using the asynchronous because you are talking with the database and there will be definitely some delay, some possibly blocking operations. So in this case, every time your application starts and makes sure that the database exists. So for example, this ensure created async method that I'm calling in here, we will call this either synchronous or asynchronous method, and you can do whatever you want in it. First of all, you have the full DB context available for you, and it's up to you what you want to do there. You can do some deletes, you can do some inserts, you can do just some querying. It's absolutely up to you. The only requirement is that you need to make sure that you are not overwriting your own data or something like that. You are not doing anything like that. So you need to check yourself that you are not overwriting all data, some columns or something like that. So in my case, I first check, hey, is there a dog named Dorka? If not, if it's a null, then I create a new one. In my case, a random GUID. At least something. Obviously, you probably want to have like hard-coded values, or even if you don't care, you can have the GUID because you have the name as like an identifier or something. And then I call save changes async and put it into database. So now if I run the application, it's probably not going to be super surprising to you. It's going to do what's in the code. So the application starts, connects to the database, and first checks, hey, is there a dog named Dorka? Well, no, because I have a fresh database. So it does the insert, and after the insert, it does the select because that's the part of my application that's there. That's the same demo as we saw quite a few times already. And now if I run it again, because I'm checking for existence of this record or something in my database, we will see that it just checks it and says, hey, nothing there, and we will continue. So every time you want to seed some data or something like that, use this method and make sure you are calling like ensure created async or some kind of like migrate async or something like that, because at that point you are applying the migrations. If you want to know all the places where this is going to be called, go to documentation and you will find all of those like 3 or 4 places where this is going to kick in, plus the synchronous and asynchronous version as well. So continuing with this piece, there is a small preview that I want to show you. As I showed you on the slides, we've also worked on a native AOT support. It's definitely not done. It's still preview. There's still a lot of like paper cuts and corner cases that are not going to work. But we want to show you the preview so you can play with it. You can give us feedback on what actually like works and you like it, or what does not work and you definitely need it, and so on and so on. But yeah, it's still in preview. If you want to play with it, definitely do so. Otherwise, do not expect it to work like 100% from the get-go. That's the reason why it's preview, and we are trying to make it work. At least that's the plan for EF10. So if you want to have like a polished experience, EF10 is going to be way better for you. So what I have in here is, again, mostly the same application as before. I need to have this magic command for now because it's not completely integrated into the native AOT publishing and this stuff. I will open my command window. I will run it. We will see that it's doing a bunch of stuff. I enabled the verbose output. And in a second, we will see that it's found this query that we have in our code on line 9 and further, and says, hey, I will be compiling this expression. It generated a bunch of files. The one I'm interested in is these EF interceptors. And it intercepted all of those calls and did some magic. You don't have to understand it. It's just like hidden for you. Normally it would be generated and you have to worry about it. And these interceptors will basically replace the original implementation of the link query and the translation and everything into something that's completely hard-coded. If you scroll a little bit down there, you will see that there's actually a piece of code that's reading from the data reader. So we have this data reader, which is a DB data reader, and it's reading GUID on the first position, and it's reading string on the second position into the breathe. And then on the third position, it's reading again the string, which will be the name, and it's setting the stuff, in this case, using the unsafe accessors. There's one small feature, or kind of like a nifty little detail that I want to show you. If we scroll a little bit in there and scroll this way, we will see, yes, you see that correctly, the full SQL statement that's actually going to be executed. We pre-generate up to some number of combinations of parameters, the full query that is going to be sent into the database. So first of all, you can quickly see what's going to be sent to the database. You can validate it. And if there is some translation problem that you would normally see in runtime, like you are calling a function that we cannot translate or something like that, now you will see it. You will get the error on compilation time because we will not be able to generate the SQL the same as before, but because we cannot generate the SQL, we cannot generate this file, and it fails, and you immediately see, oh, I wrote something that cannot be translated and I need to fix it. So that's the native AOT, quite a small, nifty little feature. So let me jump back into the slides and out of the EF and into the vector databases. You've seen me mention vector search and vector stuff on the Cosmos DB, on Azure SQL, and having support in EF on the providers on the ES side. We have also been busy working with other databases that are available at the moment, like Milvus and Pinecone or ChromaDB, and of course the Cosmos DB and Azure SQL, and making sure that we have, first of all, good support in .NET for these databases, and that we have a good support in EF, as you saw with, for example, the EF functions vector distance. But that's not it. If you've worked with a vector database, you know that these have small differences and different SDKs and different behaviors, and sometimes you want to have some abstraction on top of that. The same way you have the EF and working with relational or non-relational databases. You take the EF, you create a link query, and the nitty-gritty details of translation and how it works and the communication goes down through the ADO.NET or the SDK and the SQL or some other querying language that the database is using. So what I would like to bring your attention to is a package called Microsoft Extensions Vector Data that allows you to query or work with vector stores and vector databases in a little bit easier way, in an abstract way, and you don't have to worry about all these little nitty-gritty details. So let me jump into my last demo and make sure that we have the correct code. So what I have in my in this code is I'm actually referencing Microsoft Extensions Vector Data abstractions, I'm using the in-memory implementation for my vector store. Obviously, this is for the demo purposes only because it's easy to like restart the application, but you can use the same stuff for example, Chroma or Azure SQL throughout these connectors. And I'm using Ollama as my model, or at least embeddings generating infrastructure. So I have something that's real. In my demo, again, it's in pre-release preview. So I'm disabling some stuff, some warnings that normally would affect me the same way as you saw probably on the native IoT. I have here 3 dogs with some kind of behavior description, really not important what it is. And then I'm creating instance of the in-memory vector store. As I said, in-memory because it's super easy for the demo and I don't have to worry about having multiple data or something like that. But definitely you can use other databases as well. I create a collection if it does not exist. I insert some data with embeddings using this all mini LM model through the Ollama. And then I do the search. So as you can see, I generate the vector embedding for my query, which in my case is a family-friendly dog. So I'm looking for a family-friendly dog. I will do the vector search with options having, hey, give me the 2 most family-friendly dogs. And the property on my entity that's having the vector stuff is called embeddings. My entity in this case is slightly different. It's not a typical EF core entity, but it's still mostly something that we would be able to quickly decode. I have these vector store attributes that allow this abstraction to work with my objects and know what's going to happen. So I have this one that's key and some data. In this case, it's the name and the behavior. And also I have this vector store record vector. Basically says, hey, for this record, this property is actually my vector, my embeddings. In my case, it's called embeddings. As I used above, it's using cosine similarity, and it has a size 384 because that's the size of my my embeddings from the model that I'm using. So then I do the vectorized search, and I get the results. So you can take your guess who is the best dog for a family. Let's run this application. So it's inserting the data into memory and then doing the search. And as it turns out, Max is the best dog for a family. The second place goes to Durka. Sorry, Bella, I only selected first 2, so you are not in the result, but you would be a 3rd place. Nice as well. So unless you want to really dig down into these SDKs and doing it the one and only way for that given database, definitely look at these this Microsoft Extensions vector data package or packages and give it a try, because it might be a nice feature for you to have the same behavior as with like the relational databases where EF is doing the abstraction for you and you don't have to worry about all the small details. So back to the slides, definitely try the EF Core 9 and .NET 9. There's a bunch of nice features both in EF and .NET 9. It's, again, the best release and the fastest release, and we are super excited in the data team and EF team about work we have done. So give it a try, give us a feedback, all the preview features. Definitely, if you feel like you have some ideas, send an issue or create an issue in our repo. We are listening and we are definitely eager to see your scenarios, your real world scenarios, and your feedback, so we know what to prioritize and how to improve the features for the final version. So thank you for your attention. I hope it was interesting and you are really excited for trying the latest version of EF and everything data related. Enjoy the rest of the conference and see you next time.